Why do we even care about the molecular shape and polarity of molecules? Well, they play a huge role with how those different molecules can react within our bodies, especially when it comes to drugs. Now, stereoisomers are molecules that are going to have the exact same chemical formula. They have the exact same chemical formula. When you look at how those atoms are bonded together, they are bonded together in the exact same way. The only difference is what they look like in the 3D. Their three-dimensional shape is different. And what's so amazing about this is they have such different physical and chemical properties. Take methamphetamine as an example. When this oxygen comes out towards us and this hydrogen goes back, we have the highly addictive drug known as meth. Meth is responsible for so much tragedy in our world. Now, you take that exact same molecule, the exact same connectivity, and you make the oxygen go in a different direction. And now my hydrogen is going down, and we have vapor rub. This is used in vapor rub, not addictive, not used as a drug. So it can be pretty phenomenal that just this small little change has such vastly different results in vastly different chemical and physical properties. Now, the shape of a drug is going to define how it will react, or in some cases, not react with other molecules in our body. So we can go through and look at this molecule here and determine the shape of each of the number atoms in this molecule. So if I look at this atom right here, all I need to do is one, two, three. I have four bonds to it, which means I don't have any lone pairs. So the shape is going to be trigonal planar. My electron pair geometry is trigonal planar. Since I don't have any lone pairs, then my molecular geometry is also going to be trigonal planar. The bond angle is going to be 120 degrees. If you go through and determine the shapes for all the rest of those numbered atoms, I will, and send it to me in an email, I will give you extra credit. One thing I want to point out though is don't assume that all of the four things are already written around the atom. For example, this oxygen right here, this is not one that you're going to do, but this red atom here only has two bonds to it. So that means it only has four electrons around it. So I must have two lone pairs in order to complete the octet. This oxygen here, same thing. This red atom here, I only have two bonds to it. That's only four electrons, so there must be two lone pairs. I have to have four more electrons. So you have to be able to draw or mentally visualize those lone pair electrons. When you have really large molecules, the shape of the entire large molecule is going to depend on the geometries of each atom. And you can view this overall shape by using computer-aided software. So here is a certain molecule within our bodies, if you will, and you can blow it up so that you can look at the overall shape. Our brain chemistry is going to be a huge indicator of how drugs can react within our bodies. So we have 100 billion nerve cells called neurons, and they make up our nervous system. Neurons communicate by sending an electrical signal, and this is called action potential. It's called an action potential. And this communication happens from one cell to the next. The neurotransmitters are the chemical compounds at the end of the neuron that cross a small gap to the next neuron. They are a way to communicate this action potential. When a neurotransmitter binds with another neuron, it passes along that action potential. So that's what's going on right here. You have these, whoops, I thought I had my laser. You have this communication happening between the different neurons. The neurotransmitters then return to the original neuron through uptake channels. So you have this back and forth communication. When you introduce outside molecules, you can interfere with these uptake channels. So, cocaine is a good example of this. When you have cocaine present, it kind of clogs these channels. It's like really heavy traffic. The gap between the neurons is flooded with neurotransmitters, causing an amplification of the signal. So now I have all these neurotransmitters that are trying to communicate. And when they finally do be able to get out, you have this really big feeling. And that is your high, if you will. If we look at it a little bit closer, you can see that it completely interrupts with the signaling that is supposed to be going on.